Hello everyone. Our today's topic for the A-level chemistry 9701 is the coordination complex formation. Coordination complex. Coordination complex, the name implies that due to the formation of a coordinate covalent bond in the complex formation, that's why the name is given that coordination complexes are formed by the transition metal cations. Now, in the previous lecture, we have already discussed that the typical transition metals are those which in which the one or more ions contain partially filled d orbitals. Now, we have already discussed the electronic configuration in the previous lecture. That we are discussing, for example, iron. The electronic configuration of iron with the proton number 26 is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2 and 3d6. This is the atomic electronic configuration of iron. And this is the atomic. And if we want to write down the electronic configuration of iron positive 2, this will become 1s2, 2s2, 2p6, 3s2, 3p6. And up till now, there is the 4s2 electrons and 3d6. Now 4s electrons will be removed. As the removal of electron will be quite easy from the 4s, that's why in all the transition metal atom, first of all, during the removal, 4s electrons are removed. When 2 electrons will be removed automatically, that will be the electronic configuration of Fe positive 2. Now, for Fe positive 3, the electronic configuration from 1s to 3p will remain same. Now, what will happen? Along with the 4s2 electrons, one electron which is paired in d orbital, just like this. This is Fe positive 2 electronic configuration representation. The 4s electron has gone, and in 3d 6 electrons are present. Only one electron is paired. Whenever Fe positive 3 electronic configuration will be written, then one electron from 3d will also be removed. That will become 3d5 and 4s 0 electrons. The electronic configuration is indicating that as compared to 3d6, 3d5 electronic configuration is more stable. That's why it means this is indicating that as compared to Fe positive 2, the Fe positive 3 ions is more stable with the exact half 3d orbital. The same formula will remain applicable for the electronic configuration of all other transition metal elements. Now, this is represented by iron positive 2 electronic configuration. The 4s electron has gone, and what are the next? One unpaired electron is paired up, other are unpaired. Now, how the coordinate covalent bond will be formed by the ligands with the central metal ion. Now, the coordinate covalent bond will be formed by all the empty orbitals which are present in the central metal ion. For example, from here, 2 electrons has been removed, taken up, then 4s, 4p, 3 and 4d, 5 orbitals are empty, present. Now, it is observed that the transition metal forming 6 coordinate covalent bond with the ligands form a maximum stable coordination complexes. It means that 6 coordinate covalent bonds are formed. The number of coordinate covalent bond formed by the ligand with the central metal ion This is called as coordination number. And the central metal and the ligands represented in the parenthesis along with the charge present sometime or sometime not. This is called as a complex, coordination complex overall. Now, all these ligands form coordinate covalent bond with all these empty orbitals. For example, Fe positive 2 ion will form with 6 water molecules a coordination complex, and this complex will be represented as Fe H2O 6 times along with coordination positive 2. This is the complex represented for this. As 6 water molecules are formulating coordinate covalent bond, so this is called as a hexa aqua. Hexa means 6, aqua means water. Hexa aqua iron positive 2 ion. Hexa aqua iron positive 2 ion, it is formed by the iron 2 complex. Similarly, cobalt. Cobalt can also form 6 coordinate covalent bond. Just like water, water can also form 6 coordinate covalent bond, but water is a monodentate ligand. If we use bidentate ligand, just like 1,2-diaminoethane we have already used, that can formulate 6 coordinate covalent, 3 molecules altogether can form 6 coordinate covalent bond with the central metal atom. So this will be the complex of cobalt with the 1,2-diaminoethane, that is abbreviated as En. Now this complex can be written as COEN thrice positive 2. It means that this 1,2-diaminoethane is also a neutral ligand. That's why the charge is not including in cobalt, and cobalt charge is represented here. This can take place only when the ligands are either bidentate or polydentate, or either the ligands are very small in size. In case if the ligand is larger in size, just like chloride ion, its size is larger, then around the central metal ion available space, only few of the ligand can adjust itself around it, and that adjustment in case of larger, that will be a tetrahedral. Only 4 large sized ligands can surround around the central metal atom, and here the coordination number will also be changed. Here the coordination number of the cobalt is 6. Coordination number of iron, as I have explained the earlier complex with water, the coordination number of iron positive 2 ion is also 6. But here the coordination number of cobalt is 4. Now, as the chloride ion are negatively charged ion, 4 negative charges are present, and the positive 2 charge of cobalt is there. After adding all these charges, the overall charge comes on the complex -2. In this manner, all these These charges on the complex comes as an algebraic sum of the charges of ligands and the central metal ion. But sometimes some complexes are there where may be no charge. For example, if we have copper complex with just like this. Now, this is also a coordination complex. Water is a neutral ligand, that's why it will have a no charge. But hydroxide is negatively charged ligand, but two negative charges are cancelled out by the two positive charge of the central metal coordination metal ion. That's why the overall charge on the coordination complex will remain 0. This is also possible. Now, this is the formation of the coordination complex, and it is observed that the maximum stability comes in octahedral complexes, which are formed by the 6 coordinate covalent bond formed by the central metal ion. This is the complex formation. And there is another explanation. If we have bidentate or polydentate ligands, then another type of stereoisomerism can arise, just like this. A complex formed with the help of 1,2-diaminoethane. The mirror image of this complex cannot be superimposed. That's why this will create a geometrical or a stereoisomerism. Now, geometrical or stereoisomerism can be exhibited by the coordination complexes. This is the example of stereoisomerism. Now, another example, for example, if platinum, a complex of platinum, which are formed by the ammonia molecule and chlorine molecule, chloride ion. This is a complex, square planar complex. It is, as the two ammonia molecule as at one end and two chloride are at one end. That's why these are called as cisplatin. And this is cisplatin means the complex in which one type of the ligands are present on one side and other type on the other side. Contrary to this, there is another transplatin that can be represented just like this. NH3 Cl, NH3 and Cl. This is called transplatin. This is transplatin. It means that the coordination complexes can also show geometrical and stereoisomerism, but there are two conditions. Only geometrical isomerism will appear if the complexes has square planar structure. Square planar structure. And the stereoisomerism will be observed only and only if there are complex formed by the bidentate or polydentate. With the help of monodentate complex formation, they will not show stereoisomerism. This is the property of only bidentate or polydentate ligands. Now, those ligands which can develop a cyclic structure with the central metal ion, those are called chelates, and the complex having cyclic structure with the ligands, those are more stable as compared to the without cyclic structure coordination complexes. Now, one of the most important example of a polydentate, as we have already explained, is EDTA. 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 Ethylene diamine tetraacetic acid. The structure is represented as CH2, CH2, M and N. Here is CH2, CH2, now CH2 and CH2. Now, this will be represented just like this. This is called ethylene diamine tetraacetic acid. Now, two lone pair on each nitrogen that can also utilize for the bond formation, and when ADTA will be dissolved in the aqueous solution, automatically this proton will be removed and it will become ionized, and this will get a negative charge on each oxygen. It means that each oxygen is able to donate a pair of electron, one pair. Each oxygen is able to formulate one pair of electron. It means that if EDTA is utilized, then one EDTA molecule can form 6 coordinate covalent bond within its own molecule. 1, 2, 3, 4, 5 and 6. So the EDTA form the maximum stable coordination complex with the transition metal, because one molecule is making so many coordinate covalent bond, and secondly automatically it forms a cyclic structure with the central metal ion. That's why the complex formed by EDTA is maximum stable form. Now, all these complex formation and their properties are discussed in a variety of ways. Now, I have already explained that the transition metal complexes can show both geometrical and stereoisomerism, but there are two main conditions for the geometrical isomerism. There should be a square planar structure, and if for the stereoisomerism, the ligands should be bidentate or polydentate, otherwise this will not be observed in the coordination complexes. I thank you all.